Welcome everyone. Today we have our new episodes, and this is based on space environment and aviations. Professor Edward is very famous with this kind of things, and he has a lot of write up, lot of interesting things on space environment and aviation industry. We have our Professor Donald. Hopefully, our discussion will be very helpful for Asia Pacific, especially like university, like International Islamic University, those who are working with. Aviation industries, they are really interested to know more what's going on in North America, how we can improve, how we can contribute as a researcher, and what type of innovations we can do. I want to start from Professor Edward, then Professor Donalds. Professor Edward.
Yes, well, this is a very interesting topic for me because back when I was in high school, I was just a small student, not even in college yet, and I had an internship at Goddard Space Flight Center, NASA Goddard, 1969, during the Apollo moon landing. So I got my first baptism by fire, you might say, with the original moon landing. And I managed to get Buzz Aldrin, who was on that landing, to do a chapter in my book, Space, the Free Market Frontier. But let me give you just a little bit of background to frame this discussion, because we're in a very exciting time for the space environment. Of course, the U.S. government and the Soviet Union basically were in a kind of a race to show who could do the best and whose system was the best. And when we decided to go to the moon, and of course, obviously, the United States won that race. But the problem was that it cost a whole lot of money. The good news is that the people who got us to the moon tended to be folks who were engineers, who were people who were, not in a government bureaucracy for decades after decade. And they had a lot of freedom to think, to be creative, to say, how do we do this? There were lots of questions about how do you go to the moon? Do you have one big spaceship that simply goes there and lands, or do you have, a spaceship that a rocket that takes you to orbit, another rocket that takes you to the moon, and then another spaceship that goes down to the surface? But what happened after the moon landings was that NASA needed a goal, so to speak, and they wanted another system, and they thought, how about a reusable shuttle system so that we can maybe make a flight, ideally a flight almost every week. And with the reusable system of the space shuttle, we can bring the costs way down. This was proposed in 1985, and in the 1970s, early 1970s, as the Apollo project was being phased out. Well, the problem was this: that the space shuttle turned out to be an engineering marvel, but a very economically inefficient system. Instead of bringing the costs down, at most the shuttle could do maybe 8 or 10 flights a year. And in fact, it cost about $500 million to put one of the shuttles in space. It just was not commercially viable. During that whole time, there were private entrepreneurs who were saying, hey, why not contract out with us? Why not let us launch rockets? There was a company, Conestoga, in the early 1980s that wanted to launch a private rocket. And the problem was that they had to go through all sorts of government agencies to get permission. And it made it very difficult to do that. Well, and then in 1985, the space station was proposed. Hey, here's a place where the shuttle can fly. Isn't that great? And it was supposed to cost $8 billion. And it was supposed to be in orbit in the early 1990s and have 12 people. Well, it ended up costing about $100 billion. It was redesigned a number of times. It wasn't up until the early 2000s. And there was even a recommendation to immediately bring it back down to Earth and destroy it. Unfortunately, that didn't happen. The point is this: governments don't do a very good job of commercializing systems. And of course, what's happened in the last decade is you've had a number of regulatory changes making it easier for private companies to get involved in space, to launch rockets without having to go through years and years of getting permission. And of course, what we have seen is NASA has finally begun to contract out more for services, not for hardware, for services. And so what you saw, of course, is the advent of private companies that brought cargo to the station. And of course, the famous Elon Musk, who founded SpaceX and who, of course, has brought astronauts to the International Space Station. Jeff Bezos, of course, the founder of Amazon, has his own company, Blue Origin. I'll tell you more about Richard Branson and what he's doing in maybe a later comments. The point is this: now that private entrepreneurs are involved, they really are bringing costs down. And you really now are seeing, as a friend of mine wrote in a recent book, space is open for business. And we can talk a little bit more about that. But that's what's happening today, is that the private entrepreneurs are getting involved, bringing costs down, and really opening up a lot of opportunities. So it's a very, very exciting time to be involved in space issues. Okay.
Thank you. Thank you. Can you hear me?
Yes, I can hear you now.
Yes, Professor Donald.
Well, I'm not going to go down Edward's anti-government rat hole right now, but there's a whole other aspects to space and space science. The number one university for space science is actually UC Santa Cruz, which is right. I can basically throw a rock and hit it from here. And so what did they do? I mean, how could they be the number one university in space science? Actually, the first female astronaut was a UCSC graduate, but the truth is what Sally Ride, right? Mm-hmm. But what did they do? Since basically they're not in the business of launching rockets and doing that kind of stuff, that's not their thing. What else can you do besides having rocket ships? And so I want to give one example of that. Is I'm going to give a couple of examples. Well, first off, UC Santa Cruz manages the United States, many of the United States' biggest telescopes, optical telescopes. So when you go to Hawaii and you go all the way to the top of Mauna Kea, it says UC Santa Cruz. And they also manage the Lick Observatory and a number of other of these telescopes. So part of space is like looking out in space and finding out what's out there, not necessarily rocket ships, but and how is that valuable to us? Well, the other day, I don't know, a month or two ago, I went for my annual checkup, the eye doctor. And one of the things that the eye doctors do is they have a device that they can look at your retina and see your retina very clearly. And that's relatively new technology. And the reason that's difficult is because your eyeball is filled with this kind of jelly that distorts the view that you have of it. So when they put a light in there and they shine it and they look, well, now they get a very, very clear view. And the way that they do it is because there's computer software, there's software that basically figures out what the distortions are and reverses those distortions so that you get a very clear view. And where that software came from was astronomers. That's a good example of innovation. Astronomers had the issue of when they're looking through the atmosphere at stuff out there, the atmosphere distorts the view of what they're seeing. That's why stars twinkle. And so what they did is they eventually figured out software that basically filtered out the twinkle or changed took the distortion and reversed it so that they could get a clearer and clearer view. And so that's the software that they used. Somebody got the idea of, we can use it for optometrists. And my coffee hasn't kicked in yet. And so that's one of the examples of things that we can do. But to me, what's most interesting, and why I often read the articles in Science and Nature when they come along about the latest and greatest, is that we're starting to come to a new view of how the universe works and how the universe is put together. And we're doing it by going two different directions at the same time. One is we're looking at things that are smaller and smaller and smaller and smaller, and looking down at the quantum level, where we're looking at things like muons and hadrons and things like that. And at the same time, we're also looking farther and farther back in time. And I think, in case for anyone that doesn't realize this, light has a specific speed that it travels, which is approximately 186,000 miles a second. And it doesn't really go faster than that. I mean, in theory, it can't go faster than that. I mean, we could always figure out some new theory in the future, but that particular theory has been mostly pretty solid. I mean, I can talk about quantum entanglement, but in any event, that means that if something is billions and billions and billions of light years away, then it takes a very, very long time for it to get here. So what we're seeing is something that happened a very, very long time ago. And we're able to peer back into the origins of the universe, because the light that's reaching us was generated by events that happened so incredibly long ago that it took the light to get all this time to get to us. And we're literally able to go back to the point where we can see where stars and galaxies were starting to form that far back in time. And so why that's important, I can talk about more later. So that's that.
By the way, I don't think I necessarily disagree with Don on this. I've talked about the commercial and the aspects of space and launch costs. My original major was physics and astronomy, so I'm still an amateur astronomer. I still take my telescopes out to the mountains and bring my daughters out there so they can look at the stars. And that's the other side of going into space, is to do science. In fact, when I was an intern at Goddard Space Flight Center, and I really wasn't an expert on doing anything because I was just a high school student, I actually played around with how would you design an optical observatory on the far side of the moon, so you wouldn't have any interference from the light of the Earth or anything else. So this is very interesting to me. And of course, we have the Hubble Space Telescope up there now. We have the Kepler telescope that's discovering. I think it's discovered something like a couple thousand now planets around other stars, because we're searching for whether there's extraterrestrial intelligence out there, or whether there's planets that are similar to Earth that may have seen life originate. And of course, we have the probes on the planet Mars. I think another guest in the past has mentioned that Mars is the only planet occupied totally by robots. The Chinese, that we know of. That's right. The Chinese have just landed one. Of course, we have our latest robotic probe on Mars and a little helicopter that's going around. So this is one of the most exciting aspects of space, of course, is the science side of it. But I might add that commercialization of launches and bringing the costs of launches down also means that you can do more science. For example, one of the visions of a guy named Robert Bigelow, who was to develop private space stations that could go into orbit and be cheaper than the International Space Station, and could basically be platforms for orbiting hotels or honeymoon suites or laboratories or whatever. And in fact, he has a couple of his modules are now on the International Space Station. Now, unfortunately, his business, because of the pandemic, had shut down, and I don't think it's going to be opening again, unfortunately. But that's part of the interesting thing about space. Let me give you another example of what visionaries have been talking about for years and now could be coming, and that is space infrastructure. And let's talk right now about in low Earth orbit. Right now, if you decide you want to start a business or a research laboratory or a factory, well, there's a whole electric grid in most countries. So you can simply plug into the electric grid. There's water systems. You can simply plug into the water system. You have all of this. You have roads, of course, so you can go back and forth to where you need to get your goods or services. You can get your supplies and so forth. One of the plans, especially by the private entrepreneurs, has been to create a space infrastructure. So, for example, you create a power generation system in orbit so that if somebody wants to put a laboratory, an observatory, or whatever it is up there, then they simply can plug into the system rather than bring their own power supply. That's an example. One of the examples that has been discussed in decades past was to put huge orbiting solar collectors in space. Of course, get the energy coming from the sun from those solar collectors, and then beam it down to Earth as a power source by microwaves or some other way to provide cheap, clean power on the planet. The problem was that when you're talking about $100,000 a pound to get something into orbit, it's just prohibitive. If you could bring that cost way, way down, suddenly alternative forms of energy are possible from space. But what would happen first, I think, is that you would build out the space infrastructure so that people or either scientists or commercial activists, entrepreneurs can put something into orbit and simply plug into the infrastructure and do it that way. And so, again, commercializing space is going to help scientists. It's going to help people who are like me, astronomy fans, and it's going to help all sorts of research if you can get those launch costs down, which is what people like Elon Musk and Jeff Bezos and others are trying to do. Oh, you're muted.
Sorry, Professor Donald, can you hear me?
Yes,
okay.
I certainly can.
Actually, aviation is very interesting. I can remember I invite 2 years before some NASA scientists to Malaysia, and they visited few universities in Malaysia, like International Islamic University. People, young people really like aviation's space environment and this kind of things. So what is your advice that how they can start their career planning if they want to choose that, okay, they want to go this space environment or the aviation industry? What is the career opportunities they have, or what type of academic activities they have to finish? What do you think?
Well, the people that I know that work at NASA have a couple of different things that they do. One person I know who actually left NASA and went to Stanford, she found NASA kind of a, I don't know, unpleasant working environment, but you know, you don't have NASA in Malaysia, so it doesn't really matter. But what you're doing is one of the things that they do is that they build physical, basically airplanes that can fly very, very, very high in a sense. And so you need, in order to build mechanical things, the best choice is mechanical engineering. But besides building things, there's a whole lot of other stuff that goes on. Like my friend that was there, she was a PhD in mathematics from Cornell and had a master's degree in statistics from Stanford. And they need to be able to figure out a lot of stuff that statistics and probability are used for. And one example is, and Edward was really making me think of this, is there's so much space junk right now that it's actually dangerous for satellites because they can actually get whomped by a piece of space junk and wreck.
I think the space station got hit by something just a couple of days ago.
So how do you decide where all that stuff is going to wind up? That's where the mathematics really starts coming in, because you can, as you can identify the space junk. I mean, you see a piece of space junk flying and you've got a, rocket that Elon Musk launched. How do you know in a month that one of those pieces of space junk isn't going to hit you? I mean, it's thousands or tens of thousands of miles away from you, and it's kind of aiming in your general direction. How can you guess whether or not it's going to hit you or not? And you can't really. You have to guess. And I mean, as it gets closer, you can refine your guesses. But from far enough away, there's enough other space junk that can perturb it just by the teeny weeny force of gravity that another piece of space junk will have. That's a very complicated mathematical problem. And it's all well and good to say, well, we don't have to do math anymore. Computers will do it all for us. But don't forget, somebody has to make the algorithms in the computers that make it be able to do what it is, to make the guesses that we want. So computer science is incredibly important. If you're launching a rocket and you're trying to get to Mars, the first time we landed on Mars, I don't remember the number, but it was staggering. We landed within like 3 feet of where we thought we were going to land. So it's tens of millions of miles, goes all that way, circles Mars, and lands exactly where we expected it to. I mean, literally exactly. I mean, you couldn't even park a car that accurately. Most people can't. And how does that work? Well, that's math. That's computer science. One of the pieces that's an evolution of the spaceship that's just amazing is that this Fitbit is so incredibly much more powerful than the computers they use to go to the moon that I mean, I'd have to make interesting analogies. It's a drop of water in the ocean or something like that. I mean, and so our ability to be able to do these kinds of things, to aim precisely, to look at the space junk, to navigate, are all dependent on computers and computer science now. Yeah. That little bit that I was talking about the sparkle of the stars, well, we have a sparkle of the moon. When we're looking at the moon, it's distorted by atmosphere. When we're looking at space junk, it's distorted by atmosphere. All of those things are filtered out. And I want to mention one other thing in this particular case too, is also there's electrical engineering. And again, that mathematics is absolutely critical. It would be useless without the algorithms to tie it together. And if you've ever seen the movie Alien, there's this great array of radio telescopes. Well, we're doing things now like we're taking all the radio telescopes that are owned by some aspect of NASA or somebody else like that all over the earth. And we're tying the information from those together, which in effect makes a gigantic radio telescope that can see way, way out to the beginning of the universe, like I said. And one of the points of seeing the beginning of the universe is that it feeds back. We've had talks on nanotechnology. Well, when you get down to 5 nanometers for the little wires inside of a chip, what happens is that you're looking at matter at a level where there's basically indeterminacy, Heisenberg's uncertainty principle. So you start winding up. In fact, I know this guy, very unpleasant person. I won't say his name, but
not me, I hope.
Not you, Edward. You're a sweet guy. I may disagree with you about stuff, but I always enjoy talking to you because I feel like we always have a constructive discussion.
Agreed.
Yeah.
But tell me about this other guy.
He figured when they were getting the chips smaller and smaller and smaller and smaller and smaller, they had a problem is that electrons, cosmic rays, would hit the chips and hit the little teeny weeny little wires, and they couldn't get the chips to work right. And he's the guy who figured out for Intel how to do that and how to filter out the problem from the cosmic rays. So again, cosmic rays are astronomy. Cosmic rays, some of them at least, are residue of the Big Bang, actually.
Big Bang.
So yeah, so it's pretty incredible. So there's an example of where the biggest and oldest thing in the universe is affecting, well, the newest thing that human beings are doing right now, the smallest levels of it. And there's a lot of other things about that too that we can get to about just basically how matter works. So basically what I'm saying is that electrical engineering, mechanical engineering, and all of those require very monster math skills. So that's what you should really look at.
Thank you. Professor Edward.
Yeah, I would add to that, and I certainly agree with this, that you have to have a good technical background. And I would say across disciplines, because as we've talked about in other shows, with in an age of exponential technology, it's probably not enough just to be an expert in mathematics, or just an expert in electrical engineering, or just an expert in something else. You can probably find a market niche in the space industry or other businesses. But if you want to look a little bit wider, you really need a wider background, understand a little bit about all of these things, because what you're going to find is that as the space market develops, so to speak, there's going to be need for different things. Don is right about, for example, mathematics, and space junk is a very serious problem. I think the space station was hit by a piece of space junk just a couple of days ago. We call that the tragedy of the commons, because nobody had an incentive not to dump their trash, so to speak, in orbit. And now we're trying to figure out how to do it. But I would say something else. Those who are in universities should probably think of themselves also as entrepreneurs. The current trend with private companies like Elon Musk's and Jeff Bezos, in part started about 2 decades ago in the early 2000s, when a guy named Peter Diamandis, who was a space geek as well, decided that it was just taking NASA too long to develop, to bring costs down. So he set up the X Prize, the Space X Prize. It was modeled after the Orteig Prize, which was a prize that a gentleman put up in the late 1920s for anyone who could be the first to fly nonstop across the Atlantic Ocean. And it was a $25,000 prize, which was a lot of money at the time. And Charles Lindbergh was the first person to fly across the ocean to win, and he won the Orteig Prize. And what Peter Diamandis did was he set up the Space X Prize. He got $10 million commitment from a woman named Ansari, who was an Iranian immigrant who came over here to the United States, made a fortune, a very successful woman, and put up the money. And basically the contest was whatever party could create a spaceship that could go into suborbit twice in a 2-week period with a capacity of carrying 3 people. And that was won by a guy named Burt Rutan, who was also the inventor who created the first airplane to fly around the world nonstop. And by the way, that airplane and Spaceship One, which won the X Prize, are in the Air and Space Museum downtown Washington, D.C. right now. So anyone who visits Washington should go to that Air and Space Museum. The point is this, that Peter Diamandis had this vision of creating a prize that could spur private space ventures. And of course, it did exactly that. So you think of yourself, if you're interested in, if you're in the university, think of yourself as an entrepreneur. Look at what Elon Musk is doing right now with Starlink, putting satellites up to provide fast internet access from space. Now, there are a lot of issues, by the way, with astronomers about that, because if I'm an astronomer and I'm out on the mountain, I've got my telescope, and then suddenly I've got all these little satellites going through the picture, that's going to be a problem. But we can sort that out. The point is that entrepreneurship is important. I have one other big entrepreneurship idea and engineering idea that I'll mention in my next round. I'm keeping it so I can surprise your audience, okay?
Foreshadowing.
Foreshadowing.
Foreshadowing, yes.
Yes.
Well,
so stay tuned.
The friend that I mentioned that worked at NASA, her job actually was to try and figure out the statistical patterns of airplanes landing and taking off at airports. She basically had a problem with NASA because her boss didn't understand the math that she was doing. She had this incredibly complicated Bayesian statistical approach to it. She eventually went to Stanford, where she's working on genes. And the idea, we always talk about, oh, there's a gene, a gay gene, and there's a gene for addiction and blah, 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 like that. Well, how do you prove that? It turns out that's not really true. It's extremely complicated. Everything is an interaction of multiple genes. So she works on the question of how do genes, is the expression of a certain gene, does it cause a trait? Now, how can you prove that? Super complicated. She explains it to me, and I pretend to understand, and she really appreciates that somebody will listen to her. But she's a case in point, because she once confessed to me, she said, I don't have very good social skills. And I would say that she's probably on the autistic spectrum a little bit. I mean, she's not incapacitated particularly, but she's very, very focused and very, very good at what she does, which is specialized mathematics. So it just depends a lot on who you are. We've talked about the ability about being entrepreneurs and being and not. And being an entrepreneur is a great idea, but Elon Musk was born rich. And so some of the most successful entrepreneurs, Bill Gates's mother was on the board of directors of a bank. I remember The Economist had an article when Bill Gates's mother started to fall ill, that they were worried that without her financial management, Microsoft was in trouble. So he basically had a brilliant CFO with lots and lots of money that helped him get started. So there's kind of background stuff. I'm not saying that you should keep this as a barrier, but do remember that it costs a lot of money to do these things. And the other thing that I want to say right now is that to a large degree, or to a degree, companies really don't have an incentive to do very sophisticated research. So in other words, like if you're doing a cost benefit analysis and you're asking the question, well, what is the exact benefit of us knowing about the first picoseconds of the universe? Like, what good is that going to do us? Like, now that we've spent a huge, huge, huge fortune figuring it out, your Intel or something, now that how are we going to turn that directly into something that's going to pay us back for doing it? And I think that that's where a role of government grants. I mean, Musk got grants to do SpaceX from NASA. So, I mean, it's not like they're like one way to look at government is it's collective. I mean, in its best, we all pool our money together to do things that we couldn't individually be able to do. And so that is probably the area where it's most likely that you're going to be able to get into space, into the far reaches of space. One thing about government, and the thing that makes NASA such a pain to work for, from the people, no, some people I know love it, mind you, but the people who don't love it, they run into something that's, at least in the United States, very necessary, which is that we try and be fair to everybody. So in order to do that, we wind up kind of almost lowering the bar so that it's possible for everybody to participate. And that, has its benefits. I mean, it's fair to everybody. And there's a real question of moral hazard if we weren't fair, if we didn't have things like that, because somebody could learn to take advantage of the government and they'd get all the resources, and then somebody else, there wouldn't be resources for somebody else. And so we try and level the playing field to some degree. And that can make it a little hard if you're the person who, they say, whoever stands up, the nail that sticks up the highest gets hammered down. If you're the one that's getting hammered down, it's pretty unpleasant. Yeah. But it's a two-edged sword. Yeah. And most of the research that takes place in things like quantum physics and cosmology does take place in universities. So I agree that there's the aspect that Edward is talking about, being able to create things that allow us to be able to take advantage of what's in space. And then there's also the research area where we're doing things that may not prove fruitful. I mean, tons of research winds up, you wind up with your hypothesis, and you wind up you're wrong. There's nothing wrong with that. I mean, that's how science works, but that's not a really good idea for entrepreneurs. It's hard to find.
I've got to go off for just a minute.
Okay, no problem. Yes, Professor Donald, you continue, please.
Well, I want to get back to how exciting. There's a book I just couldn't really enjoy it, and it's called, what was it, Before the Big Bang, and it's the smallness of the intervals of time are unimaginable, really, in the time that the Big Bang happened, and it talks about.
Sorry, I have to go off.
How it was pure energy, and then that energy started to coalesce into matter, because matter is really energy. And the universe is an incredible place. I don't know if you know this, but there's what are called virtual particles. And all the time, everywhere in the most vacuum of space where there's absolutely nothing between universes. So the particles pop into existence and then pop out of existence all the time. And there's energy there. So there's energy just in just everything. I mean, even in the parts of the universe that there's apparently nothing. There's another thing that we're trying to figure, and the particles that are popping in and out are the same kind of particles that make up atoms and make up the material universe around you. So trying to understand how that takes place it's an amazing thing to try and understand. And that's what one of the things that people are doing with space science. And then one of the things that's allowed us to do to some degree is is there's actually sailboats of sorts in space, so that the energy of the light of the sun has photons that whack against the sail, and it actually can push things out in space. So understanding the little teeny molecules in the giant space itself, it's so incredibly interesting that I think that anybody who wanted to do it, I really recommend it. But it goes back to what I'm saying, which is that when you're doing stuff like that, there's really not currently any practical application to it. We'll find practical applications, I'm sure, in the future, because that's what technology is. It's taking scientific knowledge or scientific evidence and turning it into something that we can use as people. So there will be more and more technology from space. But I think where you have to go to do something like that is inside of organizations that have enough funding to be able to do that. And, in the one case, it's like Elon Musk, where the funding goes to mechanical things. And then the other places where the funding goes to basic research so we can understand the universe around us. He's frozen. Hi, Sharif. Can you hear me? Well, just the solar system's pretty cool. We're able to start going out now and looking at asteroids. We're landing on an asteroid. Think about that. Asteroids are pieces of the solar system that didn't become planets. The solar system was just dust at one point, and then that dust coalesced because of gravity into the planets and the sun. And asteroids are basically chunks of rock that didn't make it there. They might have come from a planet that fell apart, but we're still trying to figure that out. Yeah, you can just. Oh, another cool thing out in space is black holes. And black holes are stars that basically burned out. So stars just exploding all the time. It's hydrogen gas or helium gas turning into hydrogen gas, and it explodes all the time. It's just huge fireball. And then when it runs out of fuel, it collapses. And some kinds of stars that it collapses to you can see, but sometimes it collapses so that the escape velocity, the speed that it takes to get away from it, is greater than the speed of light. So nothing can escape from it. And we find them. There's one in the center of our galaxy, and we're finding more and more of them. But there's a possibility that they could form wormholes, which are places where space-time is warped to such a degree that different places in space are connected to each other. All of that stuff is stuff you could study and learn about. I mean, if you had a wormhole, it'd be like Star Trek, where you could just go through the wormhole. You'd probably get squashed if you did it, but in theory, you could go through a wormhole and be in a completely different place in the universe. It's called a Bose-Einstein bridge.
Mm-hmm. Mm-hmm.
So,
yes.
Okay, good.
Continue.
You're back.
Yes, continue, please. No problem.
Bose-Einstein bridge. It could. So we don't even. You think about gravity and mass, like say for instance, gravity. I mean, if you jump up off the ground, you go right back down on the ground. But we don't understand how that happens. Isn't that amazing? That's something that scientists are still trying to figure out. We don't understand what it is about matter that causes that to happen. And just think for space, if you could figure out how that worked and you could somehow nullify it. Anti-gravity, wouldn't that be cool? It's not impossible. We don't really know. I mean, it's not impossible because we don't know. And so space science is a lot more than building spaceships, though spaceships are very cool. Then we can get to aviation, which is building airplanes. And that is almost an unbelievable technology. Like, for instance, I was talking to a guy at GE who said that the average airplane that they build has 50,000 sensors, I think, just on the engine. And so when you're flying on an airplane, there are hundreds of thousands, if not millions, of little sensors that are all over the plane. So every second and instant, the computers in the planes know exactly what's happening, how much stress there is on the wing, how simple things like, how much the engine is going, all these different kinds of things. Like, yeah, that was it. It was 50,000 just on an engine, because GE makes the engines. They don't make the rest of the airplane. And so that's a case where you'd want to learn IoT. That's an Internet of Things application. And so learn how sensors work. And then in order for it to make sense of it, that's big data. Because if you've got 50,000 sensors on one engine pouring data back to you at high speeds, then you've got the issue of being able to understand what the data means. And again, math is the background that you have to have there, but math is just, it's entertaining if you don't apply it to anything. It's fantastically interesting, but that's not gonna get you a job working at Lockheed.
Hi. I'm back. I can only be back for a few minutes. I have some family things that happened here. But I'm going to make just a couple of final things. Since we were talking about Elon Musk, and we were talking about some of the problems of big bureaucracies, and again, I know people who work at NASA, and I used to be there as an intern myself. The problem is that you're answerable to government if something goes wrong. You have a committee, a government committee, and so forth that you have to report to. But for example, I've talked to one of Elon Musk's chief rocket designers, and he was explaining how, for example, a spaceship has these nozzles at the bottom where, of course, the fire comes out and when the spaceship goes up. And when they were doing about to do one test, the engineers went to Musk and said, well, the bottom 6 inches, there's a little teeny crack. And if it had been NASA, they would have said, well, we're going to cancel the launch. We're going to do an investigation. We're going to ask everybody for their opinion and so forth. And what Musk did was he asked his engineers, you think if we just cut off the bottom 6-inch ring and just pull it off, will it make a lot of difference? And they said, probably not. And because it was his money, he said, okay, we'll just go ahead and do that. And he did it, and the test went okay. So he made the decision very quickly, didn't have to go through committees and all. He obviously took precautions and talked to his scientists. Or another example is that a rocket often has these little teeny rockets on the side called gimbals, and they kind of move up and down to maneuver. And when he was first designing his rockets, he asked his scientist, can you find out what NASA did, because maybe we want to contract with the same people to create these little gimbals. And they came and they said it's going to cost hundreds of thousands of dollars. And it's like, well, isn't there some way to do it at a less price? So they did a little bit of research, and they found that you could buy little motors in a hobby shop for a couple of dollars that would do the same thing. And so he said, let's try that. And so he did. And the point is, it's these kind of innovations that someone like Musk is free to do. I want to mention one other thing. This is the thing I told you that I was going to save for the end. And since we're getting to the end here, I have to leave in a few minutes. We've been talking about launching rockets into orbit, which is wonderful. And we'll probably be doing that for several more decades. But the big idea that's been around for some years is a space elevator. And this is a book from 2000, 2001. I talked to the authors about it, talking about a space elevator where literally you put an elevator going all the way up to something like 32,000 miles above the Earth. And as the Earth turns, you can go up and down the elevator. Now, there's two problems. Of course, the first is an engineering problem. And this is where you need nanotechnology. And this is where you need nano materials that's strong enough to allow this to be done. And the big problem, by the way, and Don might know about this, I'm not sure, is to actually be able to string them together, the carbon nanotubes or whatever material you use, and keep them from unzipping, so to speak. That's been the big challenge. But I know that the Japanese company is working on this right now, since we're talking about the Asia Pacific area. And so that might be something that if you're thinking of what's the innovative thing, that might be one of the new innovative issues. And of course, the other thing is cost, because again, I don't deny that NASA has done some incredible things. It's just that, when you're talking about commercial access, or again, access for scientists to go up and do astronomy or whatever, you're talking about costs. And that's one of the things that they discuss in this book. Again, the book is almost 2 decades old now. But the idea of, can we do this eventually in such a cheap manner or less costly manner, so that we can have a tower literally going up to space and simply have, instead of astronauts, you'd basically have passengers going up to the tower, and then you can launch satellites from there and do other things. So if you want to think really innovatively, look into the space elevator idea. By the way, since we're talking about the Asia Pacific area, if you're interested in science fiction, Arthur C. Clarke, who spent much of his life in Sri Lanka, he loved that country and lived there for much of his life and passed away there, wrote a science fiction book called The Fountains of Paradise. And it's about a space elevator, and it takes place in Sri Lanka. So, and he calls it a different name in the novel, but that's basically what it is. And so I would recommend to your readers, if you want to be inspired by science fiction, take a look at Arthur C. Clarke's book about a space elevator. So I have to make that my concluding remark, because I have to have some other things I have to do, unfortunately. And nice to talk to you again, and hopefully your listeners found it profitable. Bye-bye, Don. I'll talk to you next time.
Bye-bye, Professor Edward. It's a really great session. Thank you. Yes, Professor Donalds, we want to go for the concluding remarks for today. And most important thing is that your support is always great for World Talent Economy Forum. And I just want to share a few of the informations, like World Talent Economy Forums we are organizing online this last 1 year. And beside that, it's almost 1 decade that we are organizing many kind of activities in academia in Asia Pacific. So we love more contributions with our research, with our academic activities, with our consulting, and most importantly, we want to organize more summit, because last summit was, I want to say, yes, we are small, but we try our level best to bring more interesting people, and many organizations now, they are very about World Talent Economy Forum. And all of our information, we have our website, wtforum.org, Asia Research and Development Institute like asiard.com, as well as we have our alnur.academy. All of our website, you get all of our content from our YouTube channel. We actually run two things. One is School of Talent Economy. Whatever we discuss before that, we organize a class. So anybody they want to use this class, they can use it, and it's 100% free. As well as this kind of policy level discussion we are organizing. And if anyone want to know more about me, my Facebook profile, my LinkedIn profile, YouTube, uh, my all of the GitHub, all of the accounts we already shares, but we want to share more of our informations. We developing all of our community more transparent, and we want like people like you, those who want to join in World Talent Economy Forum, they directly can communicate with our team and they can join. And beside that, we are actually go for fundraising option, because we have to grow. We have to grow as a think tank, as a media or academic organizations. So we need lot more support. The corporations, the governments, or the individual person, those who want to support World Talent Economy Forums, they can be our member, they can be our sponsors, or they can donate us. If they want to donate through PayPal, they can use presidentwtforum@gmail.com. We have our corporate account as well. But what is our objective? That is very important. Our objective is that we want to change human lives. So what is the main tool to change human lives? Educations, knowledge-based discussions. I'm sure what Professor Donald's, Professor Edward, like sharing with us World Talent Economy Forums. Many of our students already they are observing, or they will observe in the futures, and by this way, they can understand what's going on in the USA, what's going on in the Silicon Valley, what's going on in NASA, or in Ivy League University, Stanford or MIT. So our major objective, we want to develop a knowledge-based community, because knowledge is ultimately the strength for everyone, and this is the way how the developing nations can overcome. We have to minimize the gap in between developed nations and developing nations. Example, you always come up with a very good example of Austria, like Finland. We like it. I was in Europe. We really like how Finland, small group of people, but how they create some good example with their modern science, modern engineering, and modern technology. So we love every country around the world. We know there are many brilliant people like you, and those who can change human lives. So World Talent Economy Forum, School of Talent Economy, Asia Research and Development Institute, Al Noor Academy, we are working together. Our major objective that we want to change human lives with proper knowledge, with proper educations. So the youth community, those who want to join in World Talent Economy Forum, you can join and share our content as much as possible. Share with your government, share with your corporation, share with your academia. I'm sure they can learn very good things. So Professor Donald, you are an amazing character for World Talent Economy Forum. Always you support World Talent Economy Forum. We are really, really grateful to you. And we have hundred of speakers right now. So thank you for joining today's sessions, and I request you for the concluding remarks. We will invite you more, invite the more global communities, and we strongly believe our objective to develop a knowledge-based community who can who can solve their social problem, and they can convert their knowledge into real economy. And by this way, actually developing nations, they can change their ecosystem, change their environment, change their perception. So thank you, honorable speaker, as well as our audience, those who always support World Talent Economy Forum. We are preparing our certificates, those who contributing for World Talent Economy Forum, especially in summit. So we will send you email, all of the speaker certificates, and we want you more. We want more speakers, more knowledgeable discussions, and more effective discussions. So thank you, Professor Donald. So what's your concluding remarks for today?
Well, I want to second what Sharice just said. I try and contribute, and I'm a scientific advisor, and I've been coming up with some ideas of curriculum so that when we get into more formal education. We're developing more formal types of classes in various kinds of subjects. I mean, I talk about social networks and sociology and all these different kinds of things, but they do to really understand them in any sort of depth requires some concerted effort on the parts of the students, just like any class. And I'm really thrilled that Sharish is doing this. I'm also really thrilled of the incredible people that I meet that are on this show. I mean, it's just an honor to be Secretary General of the UN, Senator of the United States. I mean, it's just right down the line. The kinds of people that I meet are stellar. I want to just conclude by telling people something that ties together this show with a lot of other things that we've done, and to try and encourage people to think about what it would mean to be in space science, things that you can Google and things that you can research, and so that you yourself, while you're trying to make decisions about your life, can look and try and see if it's something that's interesting to you. And I want to focus on the thing that I talked about space telescopes that are radio telescopes, they call them. And what I want to point out is that the sun gives out all kinds of radiation. It gives radiation from gamma rays. It gives radiation to heat, which is infrared rays. And our human eye can only see a teeny weeny itsy bitsy bits of that radiation. And so we've got more and more tools that can see the broader spectrum of the radiation. Now, the human eye is really useful because we can see things and we can analyze them in our incredible analog digital computer that's called our brains. But there's a lot more that we don't see. And so that's a thrilling area. And if you spend some time looking at that and looking how that works, I think you'll find it's fascinating. So one of the things that we can't see is infrared rays, which is heat. And heat comes from basically space, but it also comes from the energy from space being trapped in our world. So we've talked a lot about climate change and global warming. Well, one of the things that NASA does, the space agency, is they have a network of satellites all over the world that can look at the radiation at different levels in the atmosphere. And by looking at the infrared radiation, what they're really looking at is the heat. So we are getting more and more accurate measurements of the amount of heat that's on Earth using these satellites that are up, that we've been putting up in space. That's if you're interested in climate change and trying to understand why we know 100% that global warming is taking place, go to the NASA website. They have a whole incredible sections on that, and it's really worth looking at. I want to say one other thing that along those same lines that echoes something that Edward said, which is that we're starting to put satellites to allow us to have internet connections everywhere in the world. And that is going to make a huge difference too, when you don't have to have cell towers or wires and things like that to be able to have internet access. It's going to be a little bit of a delay because light, as I said, travels at a finite speed, and they're going to be far enough away that going there and back is going to cause a teeny weeny bit of delay. But because of that, soon any place in the world will be able to get internet access. And that's another thing that we're doing by using space. So on one end, there's knowledge, and then on the other end, there's the practical applications of these knowledge, in other words, technology. And there's a lot more to it than you'd first think. It's not just a matter of sending up rocket ships. It's a huge area that's core to our evolving scientific knowledge of ourselves and the universe. So I recommend it as a very exciting profession.
Thank you. Thank you. It's really, really great guidelines for the youth community. So, the youth community from Asia, those who are observing our show, share our content as much as possible. And I'm sure this is our uh, 292 episode. So, soon we will, inshallah, we will finish our 300 episodes. So, I'm sure the 292 episode will be very, very helpful for the youth community, for policymakers, for small medium enterprise, for startup. There are many topics we are actually covering because we want to make a valuable content. We want to make lives more valuable. Like now, many the parents, especially parents, teacher, they complain, my kids, my children, they are not getting good things from social media. They are getting different kind of bad news and different kind of things, different games, which is not helpful for them. But I'm sure from our social media platform, whatever you observe, it will be life changing, it will be helpful, it will be very, very positive informations, very efficient guidelines. I'm sure suddenly a people from a remote area from Malaysia, maybe they do not get into Professor Donald's, but with his content, with today's discussions from Professor Donald's, Professor Edward, it will change your life. At least you get the guideline how to get involved with visionary projects from NASA, from Silicon Valley, and from many, many important things. This is the way you have to. You are very much lucky. I'm sure the new generation is very much lucky how they're getting different kind of support from internet and everything. So I request everyone try to learn from this kind of session, share this content, utilize this content in the classroom, whatever you want to do. If you want to develop different kind of case study, different kind of things you develop, we are ready to help you. I'm sure Professor Donald will be very happy to help youth community, to help any organization. Do your research, do your works. If you have a questions, ask questions to our mentors, to our people. They will be happy. So this is the way we can improve, this is the way we can develop better world, better ecosystem, better knowledgeable communities. Don't expend your times with lot of negative things. Try to understand what will change your life. This is the ultimately way of your career developments. So thank you, Professor Donalds. You are always very important for World Talent Economy Forum. How you contributing for us? It's really, really grateful for us. Even the Professor Edward, you, and all of the 300 speakers, those who join from 100 different countries, they are always valuable for us. So see you tomorrow. We will send our invitations. Thank you for your support. Thank you, Professor.
See you tomorrow.
Bye. Take care.
Bye.